All right, so you're going to have to enter some data in here. I just did a couple lines. You guys should have about 6. Car 1 mass, car 2, my initial of car 1, my initial of car 2, final car 1, final car 2. So we need the initial momentum. I need to compare how close the initial is to the final. They should be really close. So here's where we're going to do math. Put an equal sign. It's M1. So it's car 1 multiplied by the velocity of car 1 initial, because it is initial. And I fill that in. I should have put a parenthesis in there. My bad for forgetting. I don't want to start this video over. And then what I'm going to do is add this first car momentum to the second car's initial momentum. And I won't forget this time with the parenthesis. Car 2 multiplied by car 2 initial, which in this case is 0. I'll hit enter there. And then I'll drag that down. So I'll go back to the formula. You can see up here it's C6, which is car 1, times E6, which is car 1 initial velocity. The second parenthesis is D6, which is car 2's mass, times F6, which is, if you look here, initial velocity of car 2. We do the same thing for final. Turn the math on, put a parenthesis in here. Car 1 mass is still the same. I need to multiply that by not the initial this time, but the final. Final is car 1 final. Close up the parentheses, put a plus sign in there. Another parenthesis. Now I'm at car 2. I need to multiply that by car 2 final, which is this 1.8. Let's clean that up, or close that up, hit enter. And then let's drag that down so I don't have to do multiple formulas, and that's in there. All right, here's where it's really going to tell us how close these numbers are. I need to subtract the initial and final on the top of the division bar, and then divide it by the average of the same two numbers. So a couple things you want to do. You want to put equal sign because we're doing math. Let's put an ABS in there because I don't want a negative value. So I want to subtract these two numbers, initial minus final. It doesn't matter, we have absolute value in there. Put a negative sign in there and subtract the initial and final momentums. Then we're going to divide by the average of those same two. I don't know if I have to put this in parentheses, but I will. Average of, I'm just going to select these two cells, I6 to J6, close up the parentheses, but I got to do it twice because there's two sets in there. Hit enter and drag that down. Now that's not in percents yet. We can turn it into percents. I mean, 0.05, we could multiply by 100, but that's a bummer. You just highlight this column where you want these to turn in percents and come up here. You'll look, you could turn this into money, decimals, there's many things, dates, but we want a percent. And if you look, 5% is pretty good, 21's a little janky. Hopefully you guys will be as close to 0 as possible. Is that cool? All right, let's go on to inelastic. Inelastic's going to be the same, except if I only have one car, they're sticking together. So at the end, I just have one car. Now, granted, it's two cars stuck together, but one car, one velocity. So I got rid of a column and I combined the final velocity of just 1 and 2. So you should make that change. Otherwise, these initials and finals are almost exactly the same. If you look up here, I don't know if we have to really do it again. The initial is exactly what we did for elastic. It's car 1 times initial, car 2 times initial, but then final, you'll see I added the masses together, car 1 mass plus car 2 mass, that's D8 and E8, I'm up here now. And then I just multiply by only one velocity. So if you look up here, hopefully you can see that, that's going to be my formula in these two here. The percent difference exactly the same as what we did. If you see on this one, just to show you, I added them together and divided by 2, which is the average of the two. So again, when there's only 2 cells, using the average thing seems a little bit goofy. So hopefully that makes sense. It's just like the equation. I'll go back to final. It's just like the equation. This is the right-hand side of the equal sign. This is the left-hand side of the equal sign. So hopefully that makes sense. Explosion's a little different. All of our initials are going to be 0, so when you come into initial, you're just timesing by 0 both times. You're going to have an initial of 0. Final, it looks exactly like the elastic. We will have some here. Hopefully you remembered to write your negative signs down. Our percent difference, you have to just cancel that out. We cannot use the percent difference because we're dealing with zeros. Math and zeros generally don't go along very well. So what I'm saying is your final momentum, this column here should be super close to 0. So all I'm going to do is take what my final momentum is and turn it into a percentage. What does that mean? It just means we're kind of seeing how close we are to 0. So I'm going to put an equal sign. I'm going to click on my final momentum, and I'm going to hit enter. It's just going to take, well, I should have put an ABS in there. I'm sorry. I should have put the ABS in there so we don't get the negative number. Hopefully that works. Apparently you need a parenthesis. Sorry about that. So put a parenthesis around the cell number. It should work. There we go. Let's drag that down. Now, I already had this in percents because I copy and pasted these tables. But remember, if you're not getting a percent, highlight the table, come over here, click on percent, and it'll turn it into a percent for you. And again, you should have a bunch of tests over here. 1, 2, 3, 4, 5, maybe 6. Oh, not for explosion. My bad. You're only going to have like 3 here. 3 or 4. But, sorry, on inelastic, I didn't have that in here. Test 1, 2, 3, 4, 5, 6. You should have about 6 of those. And this should all just fill in. Now, once you get this, you're going to highlight this table. You're going to copy this table. You're going to go to wherever you're writing up your lab in. You're going to put this into your lab report. And this is going to look really good. Put those borders on there. You should know how to do that by now. We've got our test. It all fits. We've got some nice numbers. This is just a pretty table. This is awesome. You'll do that for the other 2. We have spots to put in there. And then, of course, your conclusion should have 3 parts, but each part, there's 3 parts and 3 parts in each. So it's going to be a pain in the butt. I get it. But you can do it. I know you can. All right. Any questions? Shoot me an email. Come see me. Get her done. Bye-bye.